Hi, I really want to go over quickly chapter 27, although you can't see the 7 here, kind of tell you what you need to know about this chapter from these slides and what's really not so important. So pretty quickly, just generally go over the components of blood. They're all kind of stated here, pretty self-explanatory. Big thing here is to know what the different components of the red cells are and the white cells. The life of a red cell, is 120 days. Know what granulocytes are and the different sorts of white cells that they have here. Granulocytes, neutrophils, they are the most numerous in most people. In small children, 2-3 years old, the lymphocytes are actually more numerous, and that's typical for that age group, but lymphocytes tend to be increased when you have a viral infection. So you think about young children having a lot of viral infections, so that's kind of why that makes sense. Immature white cells or neutrophils are called bands because they have a band across them when you actually look at the cells. So if you see bands on a manual differential, you won't have a manual differential unless you ask for it. You'll have a computer-read differential, and it'll just tell you neutrophils. It won't tell you bands, so you have to get a manually read differential to be able to see those small subgroups. Most of the time you don't need that, except for if you are dealing with young children or someone really sick, or you're kind of worried that you'll want to get a manual read one. They're a little bit more expensive, of course. So you want to kind of look at this. Eosinophils, you need to know what that kind of white cell is. You kind of remember those are related to parasites. Basos, we think about histamines and allergic reactions. Mast cells, same sort of thing. You see with those with allergic reactions. Okay. Lymphocytes, really going to see these more with viral infections, typically. Okay. And just in the macrophages and the dendrite cells, and so kind of go through these questions. Know what your lymphatic organisms are. Primary, secondary, so you know about your bone marrow and your thymus, but you also have to worry about your spleen, your tonsils. So if there is some theories now that if we're removing these tonsils early in young children, we may actually affect their immune system for life. Just think about that. There's probably no unnecessary organ. The more we find about stuff, the more we find out we might need that. Know about lymph nodes in your lymphatic system, and know that there is a difference. I think we learn about the circulatory system in school, but we often don't learn that there's a lymphatic system which basically runs a parallel system. And a lot of people kind of only think about lymph nodes being in your neck and under your arm, but they're everywhere, and they run their own pathway through your body. So if you have somebody that's had some part of their lymphatic system, say, removed due to cancer, or there's some other disease processes that your lymphatic system don't work correctly, they'll get a lot of edema, right? You'll see these ladies with those thick bands on their arms to decrease the edema in their arms, but you'll also see some people who just get terrible lower extremity edema. I just quickly pulled up a picture of lymphedema off the internet so you can kind of see what this looks like. Then you need to know about hemopoiesis and how red blood cells or blood cells are made, and that we start off with a stem cell that can differentiate and then become granulocytes, thrombocytes, or erythrocytes. So, and just remember that erythrocyte, as far as I know, and I think this is correct, is the only unnucleated cell in our body. So if you see nucleated RBCs, they're trying to kick out. Your body's really working hard to adjust to anemia. Alright, so we just kind of want to look through this real quickly. Like, the huge mechanisms here are not that important, but you just need to have a general knowledge of this. This is auriculocytes. So if you get a retic count, this is what they're counting is these type of early cells. So if you have anemia and you have a high retic count, your body's trying to pump out, that's doing its best to correct that. If you have anemia and you don't have any reticulocytes, your retic count is very, very low, one of two things has happened. Either your body's just kind of exhausted, it can't really take care of it anymore, or it's been so recent that it hasn't had a chance to recoup. So just kind of be aware of that. Kind of know the basic regulations in erythropoietin. So remember, the kidneys are involved here. The kidneys have it does a lot besides just filter your blood. It has a lot to do with your blood pressure and lots of different things. Kidneys are super important. Nutritional requirements, what we need to have on board in order to produce red blood cells, the iron cycle. Remember that the most common reason for anemia is GI loss, so that if you have somebody with anemia, like a non-menstruating woman with anemia, you have to think GI loss first thing, and so you want to hemocult stools to see if there's any GI loss there. And it can be very, very small amounts. So they could say there's no blood, and it just can be very small amounts, so just kind of be aware of that. Just kind of go through here, development of platelets, hemostasis, platelet counts. So typically with platelet counts, we get more worried about low platelets than high platelets. So if it's, you'll see these kind of numbers sometimes, but and you may even see slightly higher, but low platelets is something that needs to be investigated. Now, the biggest cause of low platelets is usually lab error, the specimen clotted, and it needs to be recollected, but you definitely don't want to ignore it. You want to recollect it and make sure that that's what's going on. And I've seen that even where they'll say it wasn't clotted, but then you recollect it and it's fine. So the first thing to do before you go down a big pathway of looking up stuff or worried about scaring the person is to recollect the CBC. So I have included in your resources a clotting cascade. Kind of be familiar with that because you need to know what the differences are between PT and a PTT, what you're looking for, what those are each showing you. Okay. And this is basically talking about the kids. They do tend to have more lymphocytes. We talked about that a few minutes ago. And that usually starts about, pretty early in age and lasts till they're about 4. But just think about how many times they are having viral infections. But typically for everybody else, young newborns and anybody over 4, they have more granulocytes, neutrophils than lymphocytes, okay? And those are the two big components of your white cell system. And that's kind of it for this. So just kind of generally look over this information and see you at the next chapter.